Here are some practice problems you can do to ensure you know the underlying concepts necessary to understand MO theory. Pause the video and answer these questions. Explanations for each problem will be provided in the following slides. Now let's go through the practice quiz answers. The first question was asking, what are the 5 common molecular shapes and their bond angles? At the bottom, I have listed the 5 most common molecular shapes, and here are the bond angles for each one. So for linear, since it's in a straight line, its bond angle is going to be 180 degrees. Here for trigonoplanar, you could see that there's 3 axes, each of which are separated equally, and so the bond angle is 120 degrees. The same case goes for tetrahedral, but in this case there are 4 bonds instead of 3, each of which are equally spaced, and so the bond angles between each ones are 109.5 degrees. The next one is trigonal bipyramidal. This one kind of looks like trigonoplanar, except it has 2 bonds coming out through the axial position, while there's 3 bonds in the equatorial position. And so the bond angle from an axial position to an equatorial position is 90 degrees, whereas the bond angle from one equatorial position to another equatorial position is 120 degrees, just like in trigonoplanar. The last one is octahedral. This one has 6 bonds to the central atom. All of them are equally spaced, even between the axial and the equatorial. And so all of the bond angles on this molecular shape are 90 degrees. The next question asked, what is the basic principle of the VSEPR theory? And so the VSEPR theory states that to minimize repulsions, each group of valence electrons around the central atom is located as far as possible from each other. So here in trigonoplanar, you can see that they're all equally spaced apart, and so this is the maximum distance they can be away from each other without being closer to another one. The third question asks, what is Hund's rule? And Hund's rule states that when orbitals of equal energy are available, the electron configuration of lowest energy has a max number of unpaired electrons with parallel spins. So for example, let's consider oxygen. Oxygen has 8 electrons, and so we'll just go ahead and draw these energy levels out. It's going to fill in 1s, 2s, and 2p orbitals. So this one is 1s, this one is 2s, and this one is 2p. And so we're going to fill each energy level separate from the other ones, but we're going to fill in parallel spins before we fill in opposite spins later. So for 1s and 2s, it's pretty easy because there's only one orbital. So here's the parallel spin, and then here's the opposite spin. And then same for 2s. Now, once we get to 2p, there's 3 orbitals instead of 1. And so according to Hund's rule, the max number of unpaired electrons with parallel spins will be filled first before the opposite spins are filled. And so for oxygen, we have filled in 4 electrons, so there's 4 electrons left. So what we're going to do is fill in parallel spins for 3 because there's 3 orbitals. So now that we filled in the 3 electrons for the same energy levels, we're going to fill in that last one as an opposite spin. And so what you might have thought to do was instead fill in the parallel and then the opposite spin first before filling in the other energy levels. And so you may have done this. And so then you would have had one energy level blank. But this doesn't follow Hund's rule because Hund's rule states that you need to fill in one electron for each orbital of the same energy level before you fill in the opposite spins. And so this doesn't follow Hund's rule. Number 4 asked, what is the central idea of valence bond theory? And the valence bond theory states that a covalent bond forms when orbitals of two atoms overlap with their electrons. Number 5 asked, what kind of MO is formed when adding atomic orbitals together, and where is the MO's electron density? So when you add atomic orbitals, a bonding MO is formed, which has a high electron density between the nuclei. And so number 6 was asking, what kind of MO is formed when subtracting atomic orbitals? And so when you subtract them, an anti-bonding MO is formed, which is opposite of bonding MO. And so for anti-bonding, a node is formed between the nuclei, and a node just means that there is 0 electron density there. Number 7 asks, to fill in the atomic energy level diagram for a nitrogen atom. And so here I have presented that energy level diagram. And so like oxygen, it's going to fill in the 1s, 2s, and 2p energy levels. And so remember what we said about Hund's rule, how you have to fill in the parallel spins before filling in the opposite spins of all energy levels of the same energy. And so that's why we have 3 unpaired electrons as opposed to 1 pair of electrons and 1 single electron. So that's the end of the practice quiz. If you had any trouble with these questions, I would just go ahead and review these concepts in your general chemistry textbook before you continue on with this video. If you felt confident with these questions, then let's continue.